All right, learning target 1, justify whether a relationship is a function from a description, table, or graph. We started talking about this a little bit in class today, just sort of talking in general like what a function is. And remember we kind of drew that little function machine sort of thing, where basically you've got an input, goes into the machine, something happens to it, and you get an output. And so we'll take that sort of conversation and just make it a little bit more formal with some definitions. So a function assigns each element of the domain exactly one element of the range. And the key there is this exactly one element of the range. And so that's sort of where in class we talked about, one person can only have one favorite color. One input can only have one output. You can't have one input that says, well, sometimes my favorite color is green, now my favorite color is red, now it's black, now it's purple, now it's green again. Okay, so that's where we get one output is assigned exactly one, or one input, sorry, is assigned exactly one output. The domain, these are our typically x values, not always, but typically, and this is our input. That's the way that you're probably most used to seeing. And so if you're thinking visually, kind of like we drew this in class, your domain are your inputs. And so you can probably guess what range is. These are the y values, or your output. So a function takes one element from the domain, in other words, one input, does something to it, depending on the rules of the function, and then gives one output, which is an element of the range. An example, or a few examples. These are all looking at tables, input-output tables. And so if you want to think of each of these with the whole function machine kind of visual, you're taking an input of 1, you're putting it through this machine, you're getting an output of 2. You're taking input of 2, getting an output of 4, taking an input of 3, getting an output of 6. For now, and some of you are probably already thinking of this, do not try to come up with a rule. For this one, it's fairly easy, but for now, the rule does not matter. All we're wanting to know is, does it represent a function or not? And if you go back to definition of a function, each input has exactly one output. Each domain has exactly one element of the range. Okay, and so we have 1 goes to 2, 2 goes to 4, 3 goes to 6. It's not like later 1 goes to something else. So this is a function. And again, it does not matter what this rule is. Each input has only one output. You'll probably hear me say that 1,000 times. Each input has only one output. Table B over here, we've got an input of 1 going to 1, 0 going to 2, 1 going to 5. Look at the ones for a minute. We input a 1, we get 1. We input a 1, we get 5. This is a case where 1 goes through the function machine, ends up as 2 different things. Because an input of 1 gives you 2 different values, this is not a function. The input can only match up to one output. It can only give one output. And in this case, we have an input of 1 giving 2 different outputs. Table C down here, we have inputs 1 through 6. They all map to 0, or they all match up with 0. As far as a function goes, that is fine. okay? Because each input maps to only one output. All right, 1 maps to 0, 2 maps to 0. It's not like later you have 1 mapping to 5. All right, so because each input maps to exactly one output, this is a function. If we look at some graphs, to figure out whether each one is a function or not, and this is actually just straight off your pretest. I don't know if you recognize that or not, but it is. The way that you can tell whether a graph is a function or not is by using the vertical line test. And what that means is you take some sort of, I don't know if you want to use a ruler or like your hand or what, but take some vertical line and drag it across this graph. If your vertical line intersects at only one point of the graph, it is a function. So no matter where I move this vertical line, it only intersects once with this graph of the red line here. Okay? And because it only intersects once at each point, this is a function. On this second one, I'm going along, I'm fine, it's only intersecting once. Now we've run into a problem, because now it's intersecting here and here. If it intersects at 2 points, that tells you this is not a function. If you look at this like a table, this would be a table where, say we're at x equals 5 right now. X equals 5, y equals, we'll say 1, y also equals 8. Okay, and if you go back to your previous examples with the tables, it's like this one right here, where 1 maps to 1 and 5. 5 maps to 1 and 8. That's not possible if it's a function. All right. The vertical line test, if you try it out on this next one, kind of looks like it gets close out sort of in the middle here, but it still only ever connects at one point. Okay, so the vertical line test, this passes the vertical line test, so this is a function. On the next one, we start here and we're going along and we're fine. It's only intersecting once until we get to about here, or here maybe. Okay, it looks like it maybe intersects twice. Well, now we're intersecting 1, 2, 3 times. Okay, so this is pretty obviously not passing the vertical line test because this red line is intersecting our vertical line 3 times. So this is not a function. This last one here is kind of tricky. The filled in dots basically mean it's included. The open dots mean it is not included. So if we're going along with our vertical line test, we're fine here. It's only intersecting once, still only once, still only once, still only once. As soon as we get to here, though, it looks like it's intersecting twice. But remember, this open circle means it does not count. That's not a point on this graph. Okay, so really it's only intersecting at this filled in point. It's only intersecting once. And you can keep dragging that all the way across. This is still only intersecting once because the open circle doesn't count. Still only intersecting once. Still only intersecting once. All the way across, it only intersects once ever. So that is a function. Okay, and so the vertical line test in words, a graph does not represent a function if you can draw one vertical line that crosses the graph 2 or more times. So right here we can draw a line that crosses the graph 2 or more times. So that is not a function. All right. You're before class, and we talked a little bit about this in class, but there are a lot of real-world examples that can show either functions or not. And in 7th period especially, we talked about this one right here. Actually, I guess we did in 2nd too. But According to Muslim law, one man can have 4 wives. If we kind of draw this out, we've got a man here, and there's his wife. She's beautiful. He's got these 4 identical wives. Got 4 different wives. One, in this case, element of the domain maps to 4 different elements of the range. There's not just one output for this input, okay? And so because of that, this is not a function. And so the before class is asking you to come up with an example that is a function and one that isn't. Try not to use Google, and please don't use any of the examples that were in this video or that we did in class today.